Hello, let's see how the ninth challenge from Flare On 2019 competition could be solved. The challenge was called reloaderd, and let's start with reading the message that we got with the challenge. So this is a simple challenge: enter the password, receive the key. I hear that it caused problems when trying to analyze with ghidra. Okay, so I guess the first thing we would do in such a challenge with such description, I would actually try to open it with ghidra. So let's see if it actually fails. Let's import the file. We have a file. Okay, it detects correctly p executable. Okay. And yeah, so it actually fails. We cannot import the file. There is some problem with offset address out of bounds exception. I guess it could be we could file an issue to ghidra repository about this bug, but yeah, so for now we'll not do that. Okay, so since ghidra won't help us, we can do either ida3 or radari. Both works with this challenge. I will use ida. Already have it open, so let's just open the file in ida. And yeah, so we get our main, and in the main we can actually see two functions. One is being a header that prints this nice box with the name of the challenge, and the other one is actually checking the flag. And I already indicate that it might be a fake flag. We'll see in a moment. So we get the key, so we have a function that actually gets the characters with fgets s, and then there is some kind of checks being done to see if the entered flag is correct. So like the second character is XORed with 31 hex, and we check if it's 5A, so we actually can extract the character from that. There are some additional checks like 11th is actually checked explicitly. If it's G, then there is some like simple operations done on those characters, and and the flag is checked. And if it's not correct, then we'll jump to this wrong key label. So we can convert some of those characters to ASCII. So we can get some characters of the flag. Oh, not the flag, but the key that it will give us flag. And then this key, after the checks are being done, is used to XOR this encrypted flag. And here we have some characters or some bytes values with the flag. Okay, so how we can get the actual values for the flag? So I guess we can write a Python script that will do that, and I already have it here. So I have a XOR function and the data that was visible in the disassembly, and then we generate some characters that we'll be using. So basically like ASCII letters, digits, and some extra characters. And letters will be letters plus digits. Well, it's not just letters, but this will be what we'll be iterating over, and the valid ones is that we'll be checking if everything we got is within this range. So we exclude characters that, well, flags that are outside of the printing range. And we could do it. It's like we will have to iterate through 5 characters. It's a bit much, maybe not that much, but it will take some time. But we can also a little bit simplify it, because if we go back to IDA, after this is being done and after we XOR the flag, there's one additional check being made. Let me check where it's done. So here there is this check that the flag has to have a .com in the text, and we also know that all the flags has to actually end at flare on com. flag.com. So we could also use that to actually get 4 bytes of the flag. It might be that we will already have some of those characters in our flag, because this is like basically the key. So we have already those OT, ER, and G characters we already have from those simple maths that we saw in IDA, but we still don't have the first, 3 in the middle, and 1 at the like third from the back. It would be perfect if we would get those characters, those 3 characters, because we will remove a lot of unnecessary iterations. But even if we get this, or maybe like here, it will still be improvement, because we'll not have to iterate through 5, but only 4 characters. So how we can do it? Well, we can get the last 4 characters from this data. So since we are checking that it actually ends in .com and it should end in .com, we can like do like this. So we'll just paste those characters, B, so our key will be .com, and we will just use the XOR function. I already have it defined here. And we got the part of the flag. So it's GROT. But it doesn't mean that it's actually in this order. It can be that because the key is like cycled through, so it might be that the beginning of the flag is not with G, and we can actually see. So G is this G, and OT we have here. So we actually identify the A character. So this will be R. So we don't have to iterate through A anymore. So we can delete that. We can decrease to 4, and we can remove those 2 lines. So we simplified our algorithm to find the flag. It will still take some time to actually iterate through. So I already did that before. Oh, actually I did not. So let's just run it. And we'll get something. But if we look at the data, what we actually get, it's, well, it looks like it's not really our flag, because it says like never gonna give you up, which would be someone is tricking us. So that's not very good. And if we would scroll through all those potential flags, the one that's correct is somewhere here with the 3, rot3, rotter, and herring, which is, yeah, for sure we should know that this is the fake flag, but it actually says never gonna give you up at fakeflag.com. Okay, so this is not our flag. So how can we find out what's going on? So for me, one breakthrough was that actually when I run this binary from debugger versus normal run, ideally those should be the same, but we'll see in a moment that it's actually not the same. So let's just log into our virtual machine. Okay, and let's see if we run from the debugger. So running from a debugger and just going through, let's just run. We can see the header that we saw in disassembly, and we have an enter key, and of course we can enter our found fake key and see what will happen. I have it here. Okay, and if we just go let's just exit this function just to see. Okay, so we got, here's your price, never gonna give you up at fakeflag.com. So this is what actually happening, but just for the sake of checking, let's just run without the debugger. So let's just go to flare on 09 and reload it. And if we run like this, we don't get the header. So there is no printing of this box with the name of a challenge. I don't know if that's like on purpose or something is actually not correct in my setup, but that was something that got my attention. So what I did in this situation, I have this running and then just attach to this process. And then we have to put a breakpoint somewhere. So what I did, actually, we saw that we are using fgets s to get the key. And I couldn't trust that this is actually what's happening and this is the call. So I didn't want to put any breakpoint in this binary. So what I did, I actually did something else. So I opened the ucrt base file, found the fgets function, not C, sorry, fgets, and put a breakpoint here after this call. I don't know why, but it's incorrectly showing that this is the end of the function. The end is, of course, here. So I put a breakpoint on this address, of course, in memory. And this is what we can see in the breakpoints. Here I have a breakpoint at this 78E3. Let's see, 78E3. So this is the address. And with that, we can enter a flag in our console. We need to remember it has to be 11 characters. So 2, 4, 6, 8, 10, 11. And then we'll get a breakpoint in this address, 78E3. So this is the address of the fgets. And we can just go from here to actually our user code. And this is our binary, reloaderd. And if we step through this code and we see almost similar code, and here is the XORing, we can put a breakpoint here. And if we go here, the first one is our flag. But if we look at the dump at this data, this is completely different bytes than the ones that we saw in the disassembly. So in the disassembly, it was 1C, 5C, 22, and in here we can see completely different bytes. So it's 7A, 17, 08, 34, 17, and so on and so on. So completely different data. So what we need to do, we need to take this data and actually use it for the XORing and finding the flag and not the ones that we saw in the disassembly. So let's just do that. I have those bytes here. So we can, instead of this data, we can use this. And again, here we can also find out a few bytes. But as we remember, it has to end with the bytes that we know. So here also we can go to see with this str, what are we actually checking. And if we go, it actually complete add flare dash on com. So this is what's being checked in the correct data decrypted with the XOR. So we can use it to actually find the flag in this data. So let's just do it. So we'll be looking for flare on com. So this is our bytes that we want to have. And how many bytes we have? We have 13 characters. Okay, that's very good. So let's just go to our Python. So let's just, okay, our B will be this time like this. And okay, and this is 13 characters. So let's just take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's just take 13 characters and just put them as an A in here. Okay, and then we just do the XOR and we get the key that being used to decrypt this data, and it's three-headed monkey. Okay, so now we can use that as a key. Three-headed monkey. Okay. Copying is always hard on the console. Okay, we have three-headed monkey. Now we can copy the whole array and put it as A. And again, if we run the XOR, we get the correct flag. I must have left in my other pants at flare on com. So yeah, that's the correct flag. And if we use this three-headed monkey on the binary, but run without the debugger, oh, now it's actually printed the header. So maybe it actually just detects the debugger is being run. So let's just run again. I would like to get without the header. Oh, actually I get the header again, but let's, this is not what I wanted to copy. Okay, maybe it would be easier if I would just type, but yeah. So let's try three-headed monkey. Wrong key. So actually this run is not the correct one, because we need to get this one that doesn't print the header. So maybe let's just close it again. Let's just run flare, okay, 09. Again, it's print 3. Okay, it's a strong key, but it will work with this. I don't know why it cannot print now the correct one, but anyway, so this is how we can get the flag. So actually, yeah, spotting that running without the debugger and with debugger actually produce a bit different output. I don't know why. Now it's actually I cannot get the correct. Let's just see if from here, if I run. Oh, it still prints this. Anyway, we have the flag, so this helped us to proceed to the 10th challenge, which was Mugatu. And yeah, we'll see next time how Mugatu could be solved. That was pretty difficult for me. I spent a lot of time on that, but anyway, yeah, managed to solve it. So if you like the video, I hope you learned something. Please like and subscribe. And yeah, see you next time on next challenge. Bye bye.